4. Sorry that this is so early in the morning. I know 9 o'clock doesn't seem early. Didn't seem when I decided to do it at 9 o'clock. But then when I actually had to wake up, it was kind of early. For some reason, I could not log into my email, so your parents did not get an email saying that this is happening. I did tweet, and I'll send out an email when it's done, and I can actually get into my system. The server, I guess, is something's not right with it right now, or something's not right with my internet. I don't know what. But anyways, today we're working problems 46 through 60, so let's get to it. And I didn't shut my door, so I'm letting my cats in the room. So if you hear me yelling at a cat, that's why. I probably should have kicked them out, but they wanted to be in here so bad. Oh, and then while I'm getting this started, I don't know what happened on the last Hangout. For some reason, it showed that I was muted, but I watched it back and I wasn't muted. So I don't know what was going on there. What was that? All right, well. Let me switch the screen share because for some reason that was not working. Okay. So I want to find the slope-intercept form of the equation that goes through the point 0, 3, and 1, -1. And I know I talked about we do this a couple different ways, but I don't remember offhand what was the way that we did it last week. So again, I guess we have enough of these. I'll just do it a couple different ways. All right. So the slope-intercept. All right. Well, one thing is, this is the one we did last week, wasn't it? Yeah, we did 45. Yep. Sorry. You know what? This is going to be quicker. Okay. Sorry. 46 is 0, 0, and -3, 2. Checking it. Yeah. Okay. All right. So one thing is that slope-intercept form is y equals mx plus b. And the b stands for the y-intercept. So our y-intercept is where x is 0, and they gave us that point. So that one we can go ahead and plug in. If x is 0, y is 0, so y equals 0 is our y-intercept. So plus 0. Then for the other bit, to find the slope, we have 2 points. All we need to do is find the slope between them. Okay, so I'm going to use my favorite method that I showed y'all last week, putting my 2 points. Oops, I always need to start with the smallest x, which is -3. So I went down 2 over here, and I went up 3 over here. So I went down 2 over 3. So that's my slope. Y equals -2/3 x then we don't really need the plus 0, because that's just plus 0 is the same thing as just negative 2/3 x. That looks really messy, doesn't it? Well, hopefully you can read that. Maybe I'll try GeoGebra again. It just wasn't working. I wanted to. Let me try one thing. Okay, I don't know. Sorry. All right, next one. 3, 2, and negative 3, negative 2. I'm going to switch back to GeoGebra and just try. Probably by the last one of these I do, I'll have it all figured out what programs I like to use and see my drop down menus are not pulling down. I don't know why. Okay, well, I'm just going to quit GeoGebra. It does not seem to be very nice today. And we'll just make do. Try. Okay, sorry. Three, 2, and negative 3, 2. All right. So this time they did not give us the y-intercept. So this is where we can actually get a few more methods. Use your favorite method to find slope. We already talked about those various methods. I'm going to use my favorite method. Negative 3, 2, 3, 2. We had 0 up, and we went up 6. So that's 0 over 6. So this has a slope of 0. So I have y equals 0x plus b. Well, 0 times x is just 0, and 0 plus b is just b. So I have y equals b. Okay? Then I can choose one of these points, either one of them, to plug in. I'll choose 3, 2. 3 is an x, and there is no x left in my equation, so I have nothing to plug in there. 2 is a y, so I will plug in 2 for y. So 2 equals b. Now I can go back to my original equation, y equals b, and plug in y equals 2. Okay? And I opened a different GeoGebra, so let's see if that fixed the issue. Oh, it wants me to go to a new version. Let's see. Okay, well, this seems to have helped it, so. This seems to have fixed my issues. Well, mostly fixed my issues. Okay. All right, so another way we could have done that one is plotting those points. I need to up the font size. Okay. Another way that I could have done is plotted those 2 points. Oops. Undo. Okay. Grid. It was 3, 2, and negative 3, 2. Negative 3, negative 2. Wait, did I write the wrong thing? I think I did. Yes, I did. Or I didn't see that I had written a negative. Yep, I wrote the wrong thing. Okay, sorry. Well then we'll do this one this way. So that is, my answer was incorrect for this one. Okay, and you can do this on graph paper. You don't need GeoGebra. And then connect it with a straight line. You would use a ruler or some sort of straight edge if you were doing this by hand. Okay, and then we see what is the y-intercept? The y-intercept there is 0. And we're still going to have to calculate our slope, but we could do it a different way. We could calculate rise and run. So to go from 0, 0, where it crosses the y-axis, and go up 1, 2, over 1, 2, 3. So, wait. Now I've just gone backwards, haven't I? Yes. I'm working. What am I doing? Does anyone know? I don't know. Okay. Sorry. This is the same line as the last one, is the issue, so I was getting confused. All right. But we go up to and over 3. Well, no, the other one was negative. So our slope, or our m, is 2 over 3. And then we know our b is 0, because y equals mx plus b. The b stands for the y-intercept, and it crosses at 0. So I have y equals 2/3 x plus 0, and I don't need that 0, so I could just write y equals 2/3 x. Okay? And that would be my answer. And remember, GeoGebra will tell you an equation for the line, but they don't put it in slope-intercept form. They put it in standard form. Now, it would be considered cheating to take this standard form that they give us and convert that, because that's not something that was given to you. But it could be a good way to check your answer. Okay? All right. Hopefully no more hiccups. Let's do number 48. My slope is sorry, my points are -4. Okay. -4, -8, and -4. Which button did I press? Not what I want. Sorry. Okay, -4, -8, and -4, 3. Choose your favorite slope method. whether that's graphing and actually counting, whether it's using the slope formula, or whether it's mine, which is what I'm going to use, because we talked about all those different slope methods the other day. -4, -8, and -4, 3. Okay? So this goes up, let's see, 8 to get to 0, and then 3 more past that, so that's up 11 and over 0. So the slope is 11 over 0. Uh-oh, you can't divide by 0. That means this is an undefined line. I go up 11 and over 0. I know that that undefined lines mean I have vertical lines. So when I have a vertical line, it's in terms of x equal. And what does x equal in both of these points? -4. Okay, if you're unconvinced or that confuses you and you're like, wait, I must have done something wrong, you could have plotted these 2 points, which, yeah, we're good. -4, oops. -4, -8. And -4, +3. And the only line that can connect those two things is a straight line, a straight vertical line. Y could equal anything, but x always equals 4. So my equation, as we can check with GeoGebra, is x equals 4. X equals -4. Okay? All right. I should still be able to get into my email on my phone, so if you do have questions, you can email there. I just couldn't get in, well, I just can't get in to send the message because my groups aren't on my phone. They're only on the web version. So you can still send an email for questions, and you can still, of course, tweet to @BartonMath, and I'll be checking those at the end of each section. That seems to work best instead of after every question, because there's very few people who actually watch these live. Excuse me. All right. And that's fine, as long as you're watching them. All right. Number 49 is 4, 5 and -7, 5. All right, on this one, I actually am not going to use any. I'm not going to use any graphing to help me, and do it all algebraically. Okay. All right. And since I'm doing it all algebraically, I'll even use the slope formula, which is y2. Oh, let me turn back on my drawing. y2 minus y1 over x2 minus x1. This we're going to call x1, this we're going to call y1, this we're going to call x2, this we're going to call y2. So I put in 5 minus 5 over -7 minus 4. And that's going to be 0 over -11, which is just 0. So again, I have a slope of 0, so y equals 0x plus b. Let's say you didn't recognize right off the bat that 0 times x was 0, and you just left that in there. You would then choose one of your 2 points, 4, 5 or -7, 5, to plug in. I'm going to choose 4, 5. 5 is a y, so it goes in for a y. 4 is an x, so it goes in for an x. 0 times 4 is 0 plus b equals 5. 0 plus b is just b. So b equals 5. The y-intercept equals 5. And then I plug that back into my original equation. Y equals 0x plus 5. And hopefully at this point you would recognize that 0x doesn't need to be there, because 0 times anything is 0. And you would be left with just y equals 5. Okay? Questions? Well, yeah, that was the last one, so questions. I'll do my checks. No questions. Okay. Let me close out Sketchbook Express. And then we'll keep that screen share going. Okay. And moving right along, it's the next problem is write a slope-intercept form of the equation of the line described. So we want it to go through the point 4, 5. Sorry. And we want it to be parallel to the line y equals 3/2 x plus 1. Okay. Parallel means it has the same slope. So this is my slope. So I know that my new equation, which is not the same thing as that, is going to be 3/2 x plus some new b. Okay? And then I'm going to put in my point that they gave me. 5 is a y, so it goes in for y. 4 is an x, so it goes in for x. You can either use your calculator to do this fraction or cross-canceling. 2 goes into 4 twice. 3 times 2 is 6. So 5 equals 6 plus b. Subtract 6 from both sides. That's -1 equals b. But that's not my answer. I have to take that answer and put it back into this original equation up here. So I get y equals 3/2 x minus 1. Okay? Now that's the algebraic way to do this. The next one we'll look at the graphic way. Okay? It says 51 says we want to go through to -3, and we want to be parallel to y equals 1/2 x minus 2. Okay, so let me turn back on my graph. Whatever. Okay, and the first thing I'm going to do is I'm going to graph my line. I know that my, hold on, I've got to change that, I'm sorry, I can't. There we go. Okay. I'm sorry, I'm being... Oh my God. I'm being picky. Stop. There we go. Okay, whatever, that's fine. It's just they're not squares. But okay, my point, my y-intercept is -2, so I'm going to put a dot there. And my slope is 1/2, so I go up 1 over 2. So I'm going to put a dot here. Then I'm going to connect those two dots with a line. And that's the line I want to be parallel to. Okay? And I know I want to go through 2, -3. So I'm going to come over to 2, -3 and put a dot. Put a point, rather. So there's 2, -3. And I want it to be parallel, which means I want it to have the same slope. So up 1 over 2. And then draw a line through that to see where its y-intercept is. And its y-intercept is at -5. So my line for this one is y. Oh, I'm not on the drawing. Y equals 1/2 x minus 5. Okay? And again, GeoGebra will tell you the equation of that line in standard form. You just have to check it for correctness. Okay? All right. I think personally I prefer algebraic, but we have perpendicular next. So I'll do one perpendicular, algebraic, and one graphic, and then the last two I'll probably do algebraic because it's easier for me, unless someone tweets or asks specifically for another graphic. Okay, so algebraically on this next one, click again. We have 4, 2, and perpendicular to 4x minus 3. Okay, so first thing I want to do is identify what the slope should be. If I want to be perpendicular to something, my slope needs to be an opposite reciprocal. Opposite means you change the sign. Reciprocal means you flip the fraction. So here's the slope, 4. The opposite of 4, well, sorry, let's first change that into a fraction. That's 4 over 1. So the reciprocal of that is 1 over 4. And the opposite is you make it a negative. Negative 1 over 4. Opposite means change the sign. Reciprocal means flip the fraction. So my new line is y equals -1 over 4x plus b. Now I'm going to take my point and I'm going to plug it in. 4 is an x, 2 is a y. 2 is a y, it goes in for y. -1 over 4 times 4 is an x plus b. There we go. And so now 4 goes into 4 one time, and -1 times 1 is -1. So I have 2 equals -1 plus b. Add 1 to both sides, and I get b equals 3. So my final equation is y equals -1/4 x plus 3. Remember, all of this part over here, the goal was to find the y-intercept. Okay? So once we get that, we have to plug it back into our equation. We don't stop when we find the y-intercept. Okay? All right, and then I'll do a graphic perpendicular. Okay, our point was, or our point is, let me write that down so I won't forget it. This is number 53, by the way. -4, 2, and our line is x equals 0. Okay, so first thing I'm going to do my line, x equals 0. That means that I have a vertical line going through x equals 0. I'm going to have to change these points a little bit. Hold on. So x equals 0 here, and x equals 0 here at the origin. So I can draw a line through those 2 points, and I have the line x equals 0. Okay? It's hard to see, but it is just the y-axis. And I want to be perpendicular to that, which means I have a opposite reciprocal slope. Well, the opposite of 0 is 0. There is no negative 0. So my new slope needs to be the opposite of 0 over 1. Oh, I'm sorry, guys. X equals 0. Remember, that's a vertical line. So we already had something over 0. Okay? Now, that something, that's our B, that's our y-intercept. We don't know where it's at. Okay? Because to be perpendicular to a vertical line, you need to be a horizontal line. So we want y equals something. So if I flip this, the reciprocal, I would have 0 over some number, B. Well, sorry, that's not our B. I don't know what I'm talking about. But just some number. We don't know what it is. That's a mess. 0, some number over 0 is the slope of this line because it's undefined. And then 0 over some number is the reciprocal of it. So we want a horizontal line. And we want, excuse me, we want a horizontal line going through the point -4, +2. So the only way to make a horizontal line going through that is to make a point that's on the same horizontal as that. Okay, and that line there is y equals 2. Horizontal lines are y equals, and all along that line y equals 2. So that's my answer. It's y equals 2. That was kind of a weird graphic one. So I'm going to do one more graphic one. And then the last one I'll do algebraically. We're on number 54. And we're going to do it graphically. We want to go through -3, 3. Sorry, -3, -3. And we want to be perpendicular to y equals -3x. Okay? First thing I'm going to do is make that line. -3x, that's +0, so my y-intercept is 0. Okay? And then my slope is down 3 over 1, because that's -3. Down 1, 2, 3 over 1. Be careful of scale here. My x's count by 0.5. So here's that line. Okay? And I want to be perpendicular to that. And I want my perpendicular point to go through -3. Oops, sorry. -3, -3. Okay? And to be perpendicular, I need the opposite reciprocal. So the opposite reciprocal of -3 over 1, because remember that's how we turn a whole number into a fraction, the reciprocal is -1 over 3, and then to make it the opposite, we change the sign. This is not an equal sign in between there. It's that this one changes into that one to make it perpendicular. So I want to go up 1 over 3, up 1. Remember, be careful. I'm counting by halves. So that's 1, 2, 3. And that does not look perpendicular, does it? So I want to make sure that I didn't do anything incorrectly. Just doesn't look perpendicular, does it? Well, you know, it may not, because let me try one thing. The scale being off may. Let me change it to a 1-to-1 ratio and see if. Yeah, that looks perpendicular. Sorry, it's just because the scales were off. Okay, so now I just need to write the equation of that line. And the equation of that line, we already know the slope is 1/3, so I have y equals 1/3 x, plus I need to know the y-intercept, and that's clearly shown to be -2. Normally we don't write plus -2, normally we'd write it y equals 1/3 x minus 2. Okay? And that is number 55. All right, that's number 54. So now I will do one last algebraic. And then check for questions. All right, we want to go through 0.14, and we want to be perpendicular to y equals 1/3 x minus 3. Okay? So 1/3 is my fraction. The reciprocal of that is 3/1, and the opposite is you make it negative, which is just -3. So my equation is y equals -3x plus b. I'm going to take my point I wanted to go through and plug it in. X is 1, y is 4. So plug in 4 for y and 1 for x. -3 times 1 is -3. All right, I'm going to bring this up here. Add 3 to both sides. So b equals 7. But we're not done. We take that and plug it back into, or substitute it into, that equation I had written. Y equals -3x plus 7. And now that is my answer. And you could always check it graphically. Just because we did it algebraically doesn't mean we couldn't check it graphically. But that's that. Okay? All right, check it for questions. Checking for questions. No questions there. No questions there. No questions. All right, does not appear to be any questions. So I'm going to move it right along. Move it right along to number 56. 56 says to find the value of x or y so the line through the points has the given slope. So a couple different methods on this one. Just like we had different methods, different methods for finding slope, we have different methods for finding a point that would have a given slope. Our three main methods were algebraic, using the slope formula, graphic, using rise over run, and numeric, using the little table. And since there's only 2 of these problems, and the second one's a little messy because we got undefined slope, I'm going to do all 3 on the first one, and then I'll pick whichever one I feel like doing on the second one. Probably graphic. All right, so on the first one, I'm going to do my table first because I like the table. You know, I've told you have to always start with your lowest x, but here I don't know what my lowest x is. I don't know. I don't know if my lowest x is the -3 or the x, so I'm going to have to just choose one, because I've told you have to put the lowest x. That's not exactly true. It just is easier if you start with the lowest x. Okay. All right. So I can see clearly what has happened here. We have gone down. No, we've gone up 5. Okay. And it tells me that I want to go over 4. So that means I need to add 4 to -3. -3 plus 4 is 1. So I'm going to check myself just to make sure. That's an up 5. and that is an up 4. So rise over run, 5 over 4. Yes, that's correct. Okay, that's numerically. I'll do algebraically next. Algebraically is our slope formula, y2 minus y1 over x2 minus x1. And I want that to equal 5 over 4. Okay? y2 is negative 4. y1 is negative 9. x2 is x. x1 is negative 3. Don't forget that if you're minusing a negative, you do need to put both minuses so that then you can change them to positives. Okay? And I still want that to equal 5 over 4. On the top, I have positive 5. On the bottom, I have x plus 3. And then this is just like those proportions we were solving the other week. Cross multiply. 5 times 4 is 20. And 5 times x plus 3, I'm going to go ahead and put that in parentheses. So that's 5x plus 15 equals 20. I've run out of room, so I'm going to 20 equals 5x plus 15. I'm going to just rewrite that and solve from there. Subtract 15. 5 equals 5x. Divide by 5. X equals 1, which is what I got when I did the other way. Okay? And then lastly, I'm going to do it graphically. Okay, my point is negative 3, negative 9, which I've got to move a little bit for. Okay, negative 3, negative 9. Okay, and I want my slope to be 5 over 4, and I want my other point to have a y value of negative 4. So I'm going to go up 1, 2, 3, 4, 5. Oops, sorry. This is counting by half. So 1, 2, 3, 4, 5. Oh, look, I've got that y value of negative 4 over 1, 2, 3, 4. And that's that same point, 1, negative 4, that we keep getting. Okay? All right, so on this next one, I'm definitely going to do algebra graphically because that slope undefined, I know that means I have a vertical line. I think graphically is going to be the easiest way to look at that. All right, my first point is negative 2, negative 8. So that is there. Oops. And then I want my slope to be undefined, which means I want it to be vertical. And I want my y value to be negative 5. So here's a y value of negative 5. It has to be vertical from that. There it is, negative 2, negative 5. So my answer to number 57 is that x equals negative 2. Okay? All right. Check for questions real quick, and then we'll go through 58, 59, and 60 really quickly. I don't know if y'all could tell, but I got a stylus this week, so it looks a little, my handwriting is a little bit better. All right. I see no questions, so I'm moving on. Okay. Okay. On these, we're talking about scientific notation, and we want to write these numbers in scientific notation. The first one is 0. Point 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. And then 9, 3. Ignore this slash right here. That's the decimal point. It's right there. Okay. Now, scientific notation means we have a number out front, point, another number, and then however many zeros it takes. Okay? Or sorry, number, point, another number, times times 10 to the however many zeros we had to move. If we move to the right, those are going to be negative exponents. If we move to the left, that's going to be positive exponents. Okay? So right here, to get behind the 9, I've got to move 1, 2, 3, 4, 5, 6. So I have 9.3. Got to pick my pen up between that, I guess. Times 10. How many did I say I moved? 1, 2, 3, 4, 5, 6 to the negative 6. Let me try to write that again. 9.3 times 10 to the negative 6. Okay. The next one is 1.8. It's already in the format we like. So I'm not 100% sure on this one, actually. Because, you could write it 1.8 times 10 to the 0, because we made no moves. But I don't really see the point in that. But you could. Or you could just, I guess, write it like that, because it says scientific notation. All right, next one. Gotta switch off and switch back on if I don't want it all to show back up. All right. 956,003. And here's my decimal point. So to get it behind the 9, I've got to go 1, 2, 3, 4, 5. Now, on this one, it kind of depends if we are rounding or not, because I have a couple different options. I can put it as, I can round this, and it would be 9.6 times 10 to the, how many times did I move it? 1, 2, 3, 4, 5. 10 to the 5th. If I wanted all of it, there's not much of a point in using scientific notation if you're going to use all of this, because then you didn't shorten your... The point of scientific notation is to shorten it, to make it simpler to operate with, and to... and this one doesn't simplify it at all. So I would go with this one. But I wouldn't count this one wrong. Okay? And then the last one, click off and click on. 0. My decimal points don't like me today. 0, 5, 4, 9, 6. I want my decimal point to be here, so that means I have to move it once, twice. And so that's 5 point. Again, if I'm rounding, I look at that. That's above a 5. That goes up to a 5. 5.5 times 10 to the, I only had to move it twice, but I had to move it in the negative direction. That's negative 2. Okay? If you wanted to be more exact, you would have this, but I would leave it like this. Okay? All right. Oops, I worked one more than I was supposed to, didn't I? All right, last check for questions, and then I will call it a day. All right. Y'all have a good day. Bye.